Hello everybody, we're going to talk today about section 18H, which is about definite integrals. Now, usually I would suggest that you watch this video to start, and there's a link on our Google Classroom and in our weekly planner to watch this video just to get you started on the idea of a definite integral. I'm going to walk you through a little bit of the textbook definition, and then we will get to what an integral actually calculates. So to do that, we need to go back to section 18a. We need to jump around in our book a bit and consider the area under a curve. So here we have the function x squared plus 1, and we're pretty familiar with that. It's a parabola, and its vertex is moved up 1 unit on the y-axis. And let's say we need to calculate the area under this curve. Okay, we want to find that shaded area. It would be hard because this is a curved line. So to find the area between when x equals 1 and x equals 4, we don't have a strategy for that yet. But in math, when we don't have a strategy, we think about things that we already know. So for example, if we want to find the area under a curved line, I'm going to start with area of something that I'm really sure about, which would be rectangles. I do know the formula for area of a rectangle. It's length times width. So what about if I break this shape into some rectangles? Okay, so I decide to go with rectangles that have a base of 1 and a height as high as the curve goes. So here, if I go between 1 and 2, well, f at 2 is going to be 2 squared plus 1, which is 5. Okay, between 2 and 3, I'm going to have a rectangle that goes up to a height of 10, because f at 3 is 3 squared plus 1, which is 10. So I'm going to have a rectangle that has a base of 1 and a height of 10. And here I'm going to have a rectangle that has a base of 1 and a height of 17, because f at 4 is 16 plus 1, which is 17. So I could say, well, if I found the areas of these three rectangles, 1 times 5 plus 1 times 10 plus 1 times 17, I would have an area of 32 units squared. But I can see that that's actually too much, right? I've got all this green space here that's above the curve, and I only want the area under the curve. So these rectangles, which we call the upper rectangles, because I'm going to the far end of my rectangle and drawing my rectangle across, that's an overestimate of the area. If I come over here, what if I try the lower rectangle? So that means, what if I start at 1 and make this the top of my rectangle, and then I go to 2 and I make this the top of my rectangle, go across, and this the top of my rectangle and go across. Now I'm getting some smaller rectangles, again with heights of, this would have an area of 1 times 2, this rectangle would have an area of 1 times 5, this rectangle would have an area of 1 times 10, so I'd have 3 areas, 2 plus 5 plus 10, and I'd have 17 units squared. But I can see that this method of rectangles underestimates the area, because there's all this empty space here that I'm not accounting for. So I know that 32 units is too much, and 17 units is too small. So the answer's got to be in between them. So then mathematicians think, okay, well, I don't have to make my rectangles that wide. I could actually make my rectangles smaller. So what about if I cut them in half? Okay, and I draw my rectangles across like this. I'm still making my lower rectangles. Oops. Sorry. Okay, now I've made 6 rectangles, and now that seems to cut out this white space. If I color them in, sorry, this is a little hard on my program here. Okay, if I color them in, I can see that now there's less white space. So this is a better estimate. So if I cut all of those areas in half, then I'm getting an area, and I did that to the upper rectangles on the previous slide and the lower rectangles on this slide. Now I'm getting an estimate between 20.375 and 27.875. That's better. And you can imagine that if I cut them in half again and cut them in half again, the smaller I made the base of my rectangles, the closer and closer my estimate would be. And eventually, the area of the lower rectangles and the area of the upper rectangles would converge at the total area. Now, there's more in your textbook. There's a more formal definition. I'm going to leave that as our introduction and continue in the next video.